All right, good morning, everybody. Welcome to session 2 on electrical presentation here. I'm Todd Kruze. I'm the lead mentor for 7068 currently, and I was part of 3840 for the last 5 years. We're going to give you the presentation here on electrical systems here so everyone can have a sound electrical connections on your board so that it runs forever and you can blame the mechanical guys, all right? That's what I'll do. This is Josh.
Jacob.
Sorry, Josh is right there. This is Jacob. He's going to do the first part of the presentation. At any time you guys got questions, stop us. We're here to help you benefit the most from this and get all your questions answered during this presentation. So please stop us at any point and ask questions.
I'm Jacob. I'm going to go through the first section of the presentation. I've been on an FRC team for 3 years now, and I'm going into my 4th year. All right, so we're just going to go over the basic overview of basically your electrical board. We like to make removable electrical boards that can come out of our robot completely. So this is going to include our power distribution panel, our Robo-Rio, our pneumatics control module if you have one, your voltage regulator module, your radio, your motor controllers, and your main breaker. So this is a schematic diagram for your control system. As you can see, the big gray component is your Robo-Rio. That's like your brains of the robot. You're going to have all your code downloaded onto that. As you can see, that's powered by the power distribution panel if you follow the wires back. And your power distribution panel is what breaks up all your power and distributes it throughout your robot. You'll have your battery, which all your power comes from your battery, and that goes through your main breaker, which is your negative is connected directly to your main breaker, and your hot wire will go through your, yep, sorry. So your negative connects to the PDP, the power distribution panel, and your positive goes through the main breaker, and then it breaks up and goes to your motor controllers or whatever other things you're powering. So this is your power distribution panel. It has 40 amp and 20 amp ports on it. For your motor controllers, you're going to need to use your 40 amp breakers. So your PDP is, like I said earlier, it distributes all your power to the rest of your robot. It's also where your CAN wires are going to terminate. This is your pneumatics control module. If you're using pneumatics, you'll need one of these. If you look in the red box is where it's powered. That power comes from your PDP. And then you also, in the green box, you'll see where it says CAN. For your power distribution panel, or PCM, you have to run CAN, which will also it'll be linked in with your CAN, like daisy chain. And one connection will go to the Robo-Rio and the other one will terminate at the PDP. In the purple box, you can see your solenoid channels. For your solenoids, you either have to use 12-volt solenoids or 24-volt solenoids. You can't use both of them at the same time. And then also on the yellow and green, you have your pressure switch input and your compressor output. So your pneumatics control module is basically, it's your controller for all your pneumatics devices. Voltage regulator module. So this is for your lower voltage applications. You'll power your radio with this, which is what communicates with your robot. That's how you can, your laptop will communicate with your robot via the radio with Wi-Fi. If you look in the white section, your 12-volt, 2-amp peak is where you'll wire your radio. Either you can use a barrel connector, which I would not recommend, or you can use a power over Ethernet. Don't run fans and stuff off your voltage regulator module. Motor controllers. So there's a lot of different kinds of motor controllers. Some of them have more capabilities than others. The one that our team has been using mostly is the Talon SRX. It allows you to use encoders and has a lot of capabilities, and it runs off of CAN communication. Next to it is the Victor SP, which that also it's cheaper than Talon SRX, but it runs off of PWM. There is a new Victor SPX, which came out a year or two ago, and that runs off CAN too, and it's also cheaper than the Talon SRX. In addition, there's the Spark motor controllers, which have been passed out with the KOP, the kit of parts, for the past couple of years. We used them, and we had pretty good luck with those. Those are also PWM. So the PWM, you have to route each PWM wire to the Robo-Rio for that motor controller. So each motor controller has its own wire going back to the Robo-Rio. With CAN, you just link them all together. There's also Talon SRs, which are an older version of the Talon SRX. Those run off PWM. There's some older Victors too, and those work just fine as well. Do you have any questions? Yeah.
What would you say are the major advantages to using CAN over PWM?
Probably just you don't have to route wires back and forth, and typically the motor controllers with CAN, such as like the Talon SRX, just have more capabilities.
What are any disadvantages?
Of CAN? I can't really think of any. Todd?
The disadvantage of a CAN, there really isn't. It's just a matter of choice on how you're going to route your thing on there. The CAN can be confusing. If one of the wires come loose, you will lose a lot of things on your connection. So the big disadvantage would be if one of them comes disconnected in your daisy chain, then it'd be in trouble.
So it's like the Christmas light example?
Yeah, where it's all going through it. Now it depends on where the break is and where the termination's at for your loop back on your resistor.
And are motor controllers adapted to both CAN and PWM, or is it generally one or the other?
It's one or the other, because you're going to have to choose which your programming you're going to use on there.
Which type of motor controller is more expensive?
More expensive?
Yes.
It's the Talon SRX, or $90 a piece.
Well, no, more specifically, which motor controller adapted for PWM or CAN is more expensive? Or are they about the same price?
No, they're not. The Victor SPX, it can be PWM or CAN. That's a $50 controller. Where the Talon SRXs are only CAN, and they're $90 a piece. And your Sparks and that, they're all lower end controllers.
And would you even consider like recycling Jaguars for?
You can have all you want. I'm sure there's some teams that'll download them. Andrew loves them things. Where's Andrew?
Those things.
I actually gave a bunch of mine to a co-worker that's working with the Stillwater team. I don't know if he was here from there.
Like a practice spot?
Correct. Just if you're doing a practice bot and you want to practice some Thomas code with encoders, good luck. Mr. Dean wants to say something.
I was just in the class with Big Al, and the CAN versus PWM. It sounds like the trend, not immediately, but the trend is they're going to be phasing out PWM and phasing in more of the CAN. So if you're thinking long term, think CAN is the flavor I'm getting. Is that what you thought, Andrew?
Yes,
You said that?
I was going to bring that up. I also want to ask a question, not to Todd, because I know Todd knows the answer. You mentioned the CAN bus on the PDP and the PCM. If we are using PWM motor controllers, do we have to use that CAN bus?
PWM motor controllers? Yeah, you'll have to use the CAN bus for your PCM. Your pneumatics control module requires CAN. But you're not going to link your PWM motor controllers in with that.
CAN bus is widely used. There's not hardly vehicles. My son's in the John Deere Tech program now. Some of them tractors have 7, 8 of these CAN bus readers throughout the machinery nowadays. So when he plugged into that, it was like, see, just like FRC, the CAN bus is out there being used widely. And there's different variations, and it's just a protocol that may be used with it. So if this is not the crux of our presentation, we want to move into the other portions of it, just give you an idea of some of the components as we go. So you want me to do the radio? All right. Things here with some other components on here. And just to talk about the radio, we already talked about it. The main points we want to talk about on the radio is location, location, location. Because when you get to a regional, and how many of you have been to a regional? What's the first thing you do with the programmers and that? What they got to do with that radio? They got to configure it. So they got to come off the robot because it's highly unlikely and it's not very practical to bring your whole robot up there. You can, but we prefer you guys just to bring your radio standalone up to the kiosk for programming. The other thing is location. You'll want to put it way down the drivetrain here. You want to get up and over so it's got that chance to broadcast and connect to the field management system, okay? So consider what you're doing with that, and our recommendation is using the PoE on that. And this just shows you a little PoE on here and a connection on here. And we'll cover that in a moment on specifically how to wire that and make these connections. We get them off of Amazon. You can buy 2 of these and a very good quality of them for about the same price you can buy 1 on AndyMark. But you can buy them wherever you want. But buy a good quality one. And make sure they have the 2 wires on there for the power and stuff, not just one that can break. So again, that will go right to your voltage regulator, and then your Ethernet plugs right into your radio there. You see the blue cable goes right in there, and that provides your power to your radio, and the other end goes to your robo-reel.
Something you should probably point out is it has to be passive.
Yes, I think it's on the presentation right there, on the bottom right there, passive PoE.
You will not pass inspection with an active linear jumper.
That's correct, and there's the AM is the AndyMark number. We don't go in a lot of details, but the robo-reel here, this is where Jake was talking about that the PWMs, you see that on the right side of that, that's where all them cables got to go through. And there's a 3-pin connection on that. And when we look at designing our robots, we want to make sure the robo-reel is in a good spot as well. And wiring routing is really critical where you want to run these. Because these are not very heavy gauge wire and they can bend and break and cause you nuisance issues on the field. So it's just a real-time thing. Mounting considerations. We prefer to take the robo-reel and run the 440 bolts underneath there on a little thin piece of polycarbonate and then mount that whole plate to our electrical boards. You can zip tie them. Not recommended, because these robots don't just have nice little joyride out through the field. They're getting bumped. Your autonomous, your programmers might run into the wall. You might accidentally run into the wall, or our robot might just hit you. And even though they're not supposed to breach your perimeter of your robot, sometimes it happens. And you don't want that to be bounced around. CAN bus, we've been talking about it a little bit. But just to be clear, if you're not using any pneumatic controllers or using any Talons or Victor XPX that require a CAN bus connection, you still need to have a minimum of 1 connection. You need to have that from your robo-reel. It's on the left side there, your presentation here, and it's got the yellow and it's got the green wires. They must be connected, and they should go right to your power distribution board, which is in the bottom right of your screen up there. That also has a 120 ohm resistor in there. Make sure the jumper's in the right location or you won't be able to see anything on your network, okay? These are a twisted pair. We like to ferrule them and push them right into these Wago type connections here. Here's one I said in my previous presentation. This is the one that gets a lot of people. They forget to take out the jumper. These things come with the jumper usually in them, or in the box at least. Make sure that jumper's in there. Your robot single light will not be flashing if that jumper's not in there. So there's what shows the LA and LB to turn on that flashing on there with the steady if it's on the right mode of the robot. Mounting consideration in that, this needs to be visible. So when you're planning your robot, and usually for most teams, our team included, that's the last thing that goes on the robot. Where are we going to put that thing? Because you don't want in the way of any manipulators, actuators, anything else in the robot. You can't bury it in the bottom because the FTAs on the field and stuff want to see that light. It's required by FIRST and the rules as well. Huge thing, huge, huge, huge. These battery connections, In a moment, we're going to take out the toys here with all the connectors and show you how to make these things. But batteries, your location of your battery, you know, and the direction of these. So some years we have to actually physically redo our batteries because one year we might have the battery here, we might have it like this, wherever, right? It's all on how the mechanical engineers say, hey, by the way, you got to mount the battery box, but we don't know what we're going to do with it. So you might have to redo these terminals. Make sure you make good connections with these things, and we're going to show and demonstrate that in a moment. But these things, if I come up to your pit as a control system advisor and I push on it a little bit loose, we're going to have to do it. We're going to make them new connections on there. Same with your circuit breaker on there. Use that star washer there and lock them down. Make sure they're tight. You should be checking on your pre-match checklist as well on there. Any questions on that? Again, we're just kind of going through the components. Now we're going to be moving our presentation into the actual demonstration portion of this to actually see how we should be doing these connections. Because electrical is a very key component of this matches. You can talk all the programming and all these fancy dancy actuators and manipulators we're going to put on these robots. But if they ain't staying connected, you ain't going to be moving. Josh, you up? Please label them. So if you run multiple PWMs back to your robo reel, and I say where that one on slot 1 goes, or 2, whatever, you should be able to tell me, as if you're on the electrical team, where that's wired to, what motor controller that goes to. Makes troubleshooting a lot easier.
With your labeling, don't just label it on the PWM and on the motor. Anywhere you make a connector, like with an Anderson pole or anywhere else, label both sides of that. So when you tear it all apart in the middle of a troubleshooting exercise at a regional, when you got 10 minutes, you know where everything goes back together. You don't want to put motor 1 into motor 2 or something else. You know, make sure every time you have a connection, you eliminate that point of failure with your labeling.
So on our removable boards, we do it for a couple reasons. One, the big reason is, if the mechanical guys need to go and drill tap a hole somewhere or do something where's them shavings go? They go right in there, right in the robo reel. Just make sure you're like one team and drill through your robo reel. Sorry, Dave. They know who they are. But anyways, you don't want any shavings in there because that will cause some nuisance stuff in there later on when we're trying to troubleshoot your robot if it's not working. So, and then it gives our programmers a chance to use the board for that year, start configuring everything, getting ready to go. So we can work on stuff with the mechanical engineers.
Okay, so these are some of the electrical tools that we'll use. So there's like strippers for, stripping insulation off the wire, so you get the bare wire and you can make connections. Crimpers, the one in the top middle is like for Anderson pole connectors, and then there's like the yellow ones have crimper spots for, like, I don't know what you call those.
The different connector sizes. They got the
Yeah.
red, blue, and yellow dots on them.
And then the wire strippers are also like wire cutters.
And they got numbers on it. So let's pick up one and show them all the numbers on there. So if you haven't looked at that, the wire strippers and stuff all have numbers on there. The numbers mean something. Anyone know what the numbers on the side of the strippers mean? Gauge of the wire. So don't be using a 14 gauge when you're trying to do something else, right? Because you end up taking some strands off if you go down too far.
Hey, Todd. So when we're talking about tools and stuff like that, you don't need to invest your entire budget in the year into tools. But if you have a job and you're doing the job, make sure you're using the right tool for the job, all right? And I'm not going to, I don't want to pick on this poor crimper here real quick, but If you take this one's made by Klein. I don't work for Klein, but they make a quality tool. There's not a lot of flex. You're not going to get a lot of bite. You're not going to get a lot of. You're going to get a clean cut, a clean connection, a clean strip, right? You're going to save yourself a lot of problems and those nuisances that Todd talked about. The other side of it is you can buy like the multi-connector that looks like this, but I don't know if you can hear that. Like you can actually hear it rattling. You're probably not going to have enough strength to crimp. I mean, it'll give you all your crimp sizes, but you're gonna have to crimp them so tightly. You're not necessarily going to have a good crimp. If you get one of the ratcheting ones, right, or one of the other models, you're going to get that downforce you need. The tool will actually do that for you, and it'll be the right tension. When you're stripping and stuff, those ones are a lot easier to work with because you can work with them right up here, and you're going to get a clean connection. If these teeth don't line up, you're going to get a terrible strip on these things. So make sure for some of your key electrical tools, you're getting quality tools. It's going to make doing the rest of the work 100% easier.
When making the power connections for the battery, the wires are a lot thicker than they are on than what we used to we generally use like an X-Acto knife to strip it, and then you take a hammer and just pound down the connection at the end. Is there a simpler way to do that? Just get it really big.
Well, this one's specifically designed for those type of connectors. So this crimper, this crimper will do smaller ones, but it's designed for 22 to 10 gauge.
Yeah.
What are your battery connections? Like 6, 8? They're thick. They're big ones. And so this one's actually going to be able to take on a much bigger, and you got the torsion behind it, and so you get the tight connection. You won't have to work as hard. So.
They make a wraparound wire stripper that it's just a knife that sets a depth and you spin it around it, and then you can slide it off and then you pull it out. That's for a multi-wire. You can also use that for battery cable.
So with this wire cutting, so with this like it says, you want the wires longer than you need them. So if you mess something up or you need to move stuff, you'll have wiring, you won't have to redo all your wiring. And then, so that's just helpful. It can save time. When you're stripping, strip them back about 3/8 of an inch. Sometimes you have to do longer or shorter depending on what connector you're using or crimping on. They all kind of vary a little bit. 3/8 is just kind of general. So what do you do this time?
Routing and stuff like that, right? Make sure you adjust it on here.
Yeah.
So always make them longer because mechanical engineers are still tweaking things sometimes on here. So make sure you get them long enough. So I always make sure that we put extra on there. And that just helps for routing because we maybe have to change how the routing is and that. And it's easier to cut off a couple inches than add a couple inches after we already made all the terminations on there. So this is a view of inside these wagons here on these connections. Spring loaded. So explain this is not good in the spring and that.
Okay. So, with the whiskers and stuff. So, the one picture on the left. Yeah. Okay. The picture on the left is like improper connection. So basically, they stripped the wire, and when they put it in, it just kind of got like frayed, and whiskers just kind of spread out, and then so you can see there's like wires exposed. You don't want that because it can cause shorts, or they could just fall out because they're not in there properly. Yeah.
Could you also use ferrules for those too?
Yeah, so that's what you really want to do because they keep all the wires in the same thing, and then it's firm, and you can just put them in. So, yeah, they're.
Josh, I'm going to pass around both sides. One end of these is a ferrule connector that's done correctly, where it's all clipped off and smooth, and the other side is one where you got a bunch of stuff sticking out, so you can see what it looks like when it doesn't work. So take a look at those.
Okay.
So one of the reasons we passed out the DigiKey stuff is because I've been talking to DigiKey quite often here for the vendor fair, for one. But number two is I noticed walking around the pits as my role as control system advisor, there's lack of ferrules in some of these. And this is one thing you can load up the $50 on and buy a bunch of ferrules and make good ferrule connections. And if you do it right with these square ones like that, you can just push them right in. They'll snap right in. You push it in and pull it back. So on the previous slide, you can see how these are spring loaded, right? You gotta make sure it gets in there. So then the other thing you wanna watch out as far as you don't get these too long. So you wanna get them trimmed off so they're right in there, hitting the bottom of that, making a good latch. So you should be able to go up to the robot and start pulling back on that. And I'm not saying just yank with all your force, but you should be giving a tug on these wires, and they should not pop out. Because if they do, or loose in there, you will have problems. It'll be guaranteed a problem. You don't know when it's going to show up. Might be in the final match. Might be the first match. But it's going to happen. Especially these wires, if you jam them wrong, you'll get the whiskers on there, and that's just a recipe for disaster. It could be shorting out in there.
Questions? As you're starting to build your inventory of ferrules, is there a gauge that you use the most often?
But we use the 14 gauge on some 18 gauge for your lower voltage stuff on there. And then I've been buying the 12 gauge ones for the speed controllers and stuff.
You had mentioned there's square terminals.
That's what the crimper does.
You prefer them over the round?
Yes, because these fit these terminal blocks. You can just punch them in. So you push it in, you'll just pop it in there, and then you take the thing and put it back.
We bought some rails last year, we didn't fit and all that stuff.
Right.
Not to mention the contact surface area, the round surface against the flat blade.
Yep.
There's hardly anything there, so you want to punch it.
Yep. So our recommendation is to buy the square one. Travis has got some over there, and they're a ratchet one. Just squeeze it down in there. And I prefer to get the little longer ones. And I put the wires all the way through that ferrule. I want to see the wires sticking out the end of that ferrule. Push it all the way to the insulation, like this picture up here in the top right here. Push it all the way and see how the wires are going past the ferrule portion of it on the metal. Push it in tight, then crimp it. And then, if you need to, you can just trim that off square with so it looks like the bottom middle picture, right? All my wires are in there contained. And then when Dave was saying, when you push it in there, it's got that surge comes down, and you should be able to push it all the way to the end, and it'll snap right in there, and it won't come out. We rarely have electrical issues on our robots. And we do it nice and neat and put everything on there. And this is one of the reasons why. Good connections on here.
So proper wire crimping. So you can see on that style connector they have, there's proper ways to do it. You have to position them in the crimper properly to get a good connection and make sure they stay crimped and they stay in the connector. Just go to
Same thing. You want to get them all the way through and see how the blue will match up with the blue dot. The red ones will match with the red, and so that it's designed for that size connector. That's what the blue dots and the red dots and yellow dots are on that crimping tool is used for. Now, one of the things you can do to ensure this on here, you can crimp them down like that. We have on our old Talon SRXs and even on our spark controls we've used, we've actually tore the insulation off there and soldered it and then put shrink tube over it. That's another option you can do if you don't trust your crimping abilities. But part of it is just using the crimper tool correctly. The diagram shows you which way you should be putting it. It's got that little slit in there. Make sure that is on the opposite side where the dimple is on there when it's pressing down, or else it won't fold over and do a good crimp on there.
And a lot of this is stuff you should be doing off-season. The first time you do an Anderson pole connector, the first time you do a battery connection, or the first time you do something for one of your motor controllers, don't make that the first time you put it on your robot. I know that seems really like common sense, but everybody practices programming, they practice motors, they practice building drivetrains. And I don't know how many of you guys practice doing electrical, or taking time to really get that right before, with your teams, with your electrical groups. But don't let it be the first time you do that connector. Don't let that connector be an experiment on your competition robot, right?
So Anderson pole connectors, These are really good. We use them. So you crimp a piece on the end of the wire, and then there's a little plastic clip that goes over it, and then they clip together, so it's like a wire-to-wire connection. We use them on all of our motor controllers. So we'll put them on the motor controllers, and then you can just disconnect the motor controllers if you're going to reuse them for your next year's robot. You just unplug them, put them on your new robot, and then you just wire up your new wires or leads or whatever to your motors or terminal block, and then you just plug them in your motor controller.
Passing around both pieces, they don't come pre-done.
Done.
So you actually have to do the conductor piece that clips on, and then they have to be inserted into one of these plastic things. The plastic things actually, when you get them all done, you can slide them together too, so they're more modular. You get two pieces. So you got to crimp on the metal part first, then insert it into the plastic.
It's a tricky thing to do the first time you do it. So like Travis just mentioned, please practice this right now before you go to your Christmas breaks. If you really can't get it, there's a really good online video. Just Google the answer pole connector. I showed one student last year, and she made like 20 of these in like no time. Once she got it down, she was good at it, and she just went to town on do it. So we do long wires and just do a bunch of these, so when we get ready to wire the rest of the robot, all our connectors are ready to go with the leads on it. It snaps in there, and it's got to snap onto that plastic thing. You'll see how the spring is, and it goes into that latch so they don't come loose. Now, let's talk to Rob back there. You can solder these two, put a little solder in if you want, but be careful you don't get a lot of solder on there, because then it could hang up in the plastic connector. So these are great things to use, but if they're done improperly, you will have issues, and that's why we're here today to help teams do better at electrical connections. As a CSA, I have seen these melt. And they draw a current on that drivetrain, and if it's a loose connection inside there and it's sitting there arcing all during the match, it melted these connectors down. So just be aware of that. Don't be scared to use them, but practice it. And once you do it, when you push that wire in, you'll hear it click, and that's what you want to do. You want to hear it click in there.
They'll give you instant feedback. There's no they're almost right. They're either right or they're not right. And like you said, if you get the click, they're right. Do a tug test. I mean, you can take them apart, but you're going to be like, oh, that, and then it pops off, right? If you just pull them lightly, like minimal force, and they come apart, that's not right, right? And because the two pieces, those metal pieces I passed, they'll lock into each other this way. They'll pull, they'll click into place, they'll snap in. If not, they'll just come up over each other like this, and they slide right up. Right, so it's very instant feedback if you do a tug test on them.
Maybe you want to pass this around. This is the tool for it. It's on the screen, but there's a method of putting them in there and seating them all the way down, and then you just close it down with the ratchet. But then they get that crimp on there. But if you don't have this tool and you want to use the answer pole connectors, I would recommend getting this tool because it's one that works well with it.
One thing that's important about those connectors is that you strip the wires off to the right length. If it's just like, I was showing someone this last night, and he did it, and it clicked. It actually clicked like Travis was talking about, but it didn't actually latch over that piece. And so if you don't, if you leave too much wire hanging out of there, it'll butt into that plastic piece, and it won't make it to the point where it latches all the way over that other metal piece in there. And that's what will cause it to just fall right out.
I'll pass around the Ferrule connector one Tuesday and look at how the square one works.
So if you don't have a session for session 5, we're doing this presentation again, but that one we're going to do where hands-on. It's going to be more of a discussion, not into the details. So if you want to come and practice that, come to the 5th session. If you're thinking, I don't know what I'm going to do that session, come here. We have the tools. We have wire. You can come in and we'll demonstrate it, and we'll let you do the connection too. So if you're still in doubt, just come see us then. Soldering stuff, I mean, no one should be using the one on the right. If you are, good luck. It's kind of hard to maintain your temperatures. Should be using soldering iron.
So, soldering techniques, just things to do before you're soldering. You want to make sure your wires are stripped to like the length you want, and they're clean, and you want to tint them. So basically you heat up the wire with a soldering iron, and you just put a small like coating on there of solder just to cover the wires and hold them together before you like solder two wires together. It adds a
Wet sponge for the wipe off excess.
yeah, and then you want like a wet sponge to wipe off extra like solder from your soldering iron, so you don't like have extra, I don't know,
Sorry, just keeps
just
the tip
extra
clean.
solder. Yeah, it keeps the tip clean.
Take sure.
Solder wet or a solder sucker? That's more like bigger investments.
You know, I've used both, and the wicking is great for PC boards on there. Usually the sucker, if you're trying to do it off of a wire, it's usually use the sucker to suck the solder as you're melting it off. Sometimes it's hard. You can wrap it on there and kind of heat it up. That's a little more trickier. If you got little clips and holder, it's easier to do it that way too. Shrink tubing.
I'm feeling lightheaded here.
So on the shrink tube, when we do that, so we were talking earlier on the POE. This is our official way that we recommend doing this, is when these come, they have the barrel connector now. We just cut it off, strip it back. There's two wires in there, the black and the red in there. And what we like to do is take individual wires, saw them together, shrink tube each individual red wire and the black wire together, and then run shrink tube over the whole thing, shrink it down. And then we've got a solid connection on here. And this will go to the voltage regulator, right? So that's how we like to use it, and we use shrink tube a lot on there. You can use it on the other connectors as well to keep all the things inside and protect your wires. You can use different colors as well in there. We talk about labeling. Again, it doesn't matter what scheme you use. I love to have the students write out this thing and draw this on a piece of paper and actually write on it. Here's drive 1, motor 1, drive 2, whatever. This is left motor, this is the right motor, this is the left motor 2, whatever it is on your thing. You can take one motor, you can take 2, lift, whatever we're doing. We like to have that all out. There's flags. We actually have a labeler that we got donated to us. So we label a lot of ours with little flags like that. You can buy the plastic ones as well. Color coding works great. You can match them all up. Some type on there is great. At the end of the day, you gotta look at the rules. When the game manual comes out on January 5th this year in 2019, just look at the game manual. It's usually in section 4, and that will override anything in it. Budgets and constraints, right? You can buy different components on there. Usually it was $400. I think it's moved up about $5 now, $450, and you can't go over $4,000 for your whole entire budget. So you got your investment in your tools and that, and then design considerations, say for your Talons or your Victors or your Sparks. It all depends on what you're going to use it for. But on them terminals on there, make sure you lock them down. Someone asked about Loctite. I like to use Loctite a little bit on there. Don't use the red stuff. You might never get it off. Blue stuff usually works on there. On your screw terminals on the Sparks in particular and the SRXs. So if you come up on the way out and you want to look at our board on the Talon our SRs, you'll see that we took the insulation off and actually soldered it and shrink tubed over it. Make a good solid connection on that. Is there any questions? Feel free to come back 5th hour if you just want to do some connections. Yes?
Some of the numbering systems of the rules will be changed this year, so just be aware that those numbers may not be the same section numbers.
Correct. It's usually 4, but it can be changed.
I know it.
Yep.
I know they're changing.
Okay, good. What? Tools? Oh yeah, you watch the gates. Thanks everyone for attending. Good luck in the 2019 season coming up.